Good morning everyone. Today we will present our group assignment for application of mathematics and statistics in business. Our study focus on insurance policy holder data analysis using SPSS. This study using a dataset containing 1,338 insurance policy holders. The dataset includes variables such as age, gender, BMI, number of children, smoking status, region, and insurance charges. The purpose of this analysis is to understand factors that may affect insurance charges and to gain useful business insight. For sampling, we use the simple random sampling method. A total of 498 respondents were selected using the random sample of cases function in SPSS. Every respondent had an equal chance of being selected, which made the sample fair and unbiased.
My name is SUKANYAA CHANDEE anak perempuan NIM, matric number A23A1702. Today I want to present about section 3.0. We focus on descriptive statistics which used to summarize and understand the data set. In this study, we analyzed 498 respondents using variables such as BMI, number of children, and also insurance charges. The purpose of this section is identify the general patterns and trends in a data before moving to more advanced statistical analysis. This step is important because it helps us understand the overall structure of data and avoid incorrect conclusion later. Next, we move for section 3.1, numerical descriptive measures. We analyze the numerical data using means, medians, and percentage. For age, about 50% of respondents are below 39 years, showing a balanced distribution. For BMI, the majority fall into overweight category, with indicators highest health risks. For number of children, 45.4% of respondents have one child, making it the majority group. For insurance charges, about 75% of respondents pay lower or moderate premiums, while only around 25% pay high premiums. This shows that the data of positively skewed, meaning a small group of high-risk individuals increased to over average. For section 3.2, graphical representation, we use graphs to better understand the data distribution. From the smoker distributions, about 79 are non-smokers, which is a majority, while 21% are smokers, representing the minority group. This means most respondents are low-risk individuals, but the smaller group of smokers represents higher health risks. From the histogram of insurance charges, around 70 until 75% of respondents pay lower premiums, while only about 25% pay very high premiums. This shows that insurance pricing is based on risk, where a small group of high-risk individuals is charged significantly more. Overall, the graph confirms that the majority are low risk, while the minority group has a strong impact on insurance costs.
Hi, today we will explore section 4.0 of our study, which is inferential statistics, and we will focus specifically on how we use hypothesis testing to move from simple data observation to meaningful population-wide generalization. At its core, hypothesis testing is the formal engine of inferential statistics, and it allows us to evaluate whether the patterns we see in our sample data actually support a broader claim about the population at large. The process begins with a binary framework, and we establish a null hypothesis, which is the status quo, and alternative hypothesis, which is our research claim. We then use p-value and predetermine significance levels to decide which hypothesis the evidence supports, And for our primary objective here is to filter out the noise. And for example, like when we ask, is the relationship we found statistically meaningful or is it just a fluke random chance? So inferential technique help us to ensure our conclusions are valid. So in this study, we apply these methods to two key areas. And for the first one, we look at factors that related to smoking habits. We specifically wanted to know if age plays a significant role in smoking proportions. And to answer this, we conducted an independent sample test, and this compared the proportion of smokers between two distinct age groups, which is 18 years old and 20 years old, testing for a statistically significant variance. As shown in our comparison, while there are differences in the proportion of smokers at age 18 versus age 20, the t-test determines if this gap is wide enough to be considered a population-level trend. And our second focus area was insurance pricing. Specifically, we examined whether an individual region of residence influenced the insurance charge they incur. For this multi-group comparison, we utilize a one-way ANOVA, and this allows us to access variations across several regions simultaneously to identify if geography is a significant pricing driver. This data visualization breaks down the charge by region, and the ANOVA test help us to understand if the difference in these slices are statistically significant or just a result of sample variability. So, by combining test and ANOVA, we gain a comprehensive view of how demographic and also geographic factors related to insurance pricing. So these tools allow us to make generalizations that are both accurate and actionable. Next is 4.2, and we will examine the specific application of our independent sample test. And in this phase of the study, we look directly at whether age plays a statistically significant role in smoking behavior by comparing the 18 years old and 20 years old group. Now let's take a look at our sample breakdown. And out of 39 total individuals that was analyzed, there is only 28 belong to the 18 years old group, and while there is only 11 that belong to the 20 years old group. When we look at the descriptive average, the mean proportion of smokers among 18 years old is 0.1071, while the 20 years old group record a noticeably higher mean of 0.2727. The descriptive statistic clearly suggests an initial difference in smoking rates between the two ages, and additionally, the standard deviation for the 20 years old group is 0.46710, and to compare it to the 0.31497 for the 18 years old group. This higher standard deviation indicates that a much greater variation in smoking behavior as individuals turn slightly older. However, we cannot rely on descriptive data alone, but we need a formal test to confirm if this gap is meaningful or just a random chance. So, to test this formally, We establish our statistical binary. Our null hypothesis states that there is no significant difference in the mean smoking rate between the two age groups, but our alternative hypothesis claims that a significant difference does exist. So before evaluating our t-test, we must check our mathematical assumptions using Levin's test for equality of variance. The test yielded a significance value of 0.021 because this p-value is less than 0.05 and the assumption of equal variance is officially violated. Therefore, to remain statistically accurate, we must adjust our length and use the equal variance, not assumed dataset row. And looking at the adjusted row, the independent sample t-test generate a t-value of -1.083 with 13.729 degrees of freedom, and this calculated test statistic results in a two-sided p-value of 0.297, and because of our p-value, 0.297 is substantially higher than our 0.05 significance threshold. We fail to reject the null hypothesis, but even the 20-years-old show a descriptively higher mean. So the mathematical reality is that the difference is not even large enough to be statistically significant. So, conclusion, this proves that age between 18 and 20 is not a critical factor driving smoking status within this dataset. Thank you.
Hi, my name is Jessie Tan and my card metric number is A23A1571. I will be presenting section 4.3, which is the analysis of variance, or ANOVA. ANOVA is a statistical technique used to compare the means of three or more groups. In this study, ANOVA was used to determine whether the mean age difference among respondents with one child, two children, and three children. The significant level used was 0.05. The null hypothesis states that there is no significant difference in mean age among the group, while the alternative hypothesis states that there is a significant difference exists. Based on the descriptive statistic as you can see, respondents with one child has a mean age of 40.29 years. Respondents with two children had a mean age of 40.41 years. And respondents with three children had the highest mean age of 43.22 years. However, the difference among the groups were relatively small. The one-way ANOVA test produced an F-value of 1.169 and a p-value of 0.312. Since the p-value is greater than 0.05, we fail to reject the null hypothesis. This indicates that there is no statistically significant difference in mean age among respondents with different numbers of children. In conclusion, although respondents with three children appear slightly older on average, the observed differences are not statistically significant. Therefore, the number of children does not significantly affect respondents' age in this sample. Thank you.
My name is SUBRAMANIAN. My metric number is A23A1825. So lastly, I would like to conclude our statistic analysis. First, a simple random sampling method was used to select 498 respondents, ensuring the sample was fair and reliable for analysis. From the descriptive statistic, we found that most respondents were non-smokers and the majority paid low to moderate insurance charges. The insurance charges also showed positively skewed distribution, meaning only a small group paid very high premiums. Next, based on the inferential statistic, the independent sample t-test showed that there was no significant difference in smoking rates between 18 years old and 20 years old because the p-value was greater than 0.05. Similarly, the ANOVA test found no significant difference in mean age based on the number of children. Overall, this study shows that statistical analysis is useful in understanding customer patterns and supporting better business decisions, especially in insurance risk assessment and premium settings. Thank you.